Good morning guys, welcome back to my YouTube channel, welcome back to Civil Tech, where we solve strength of material, we solve beams of such. So guys, today we have a beam to solve with variables. We have P, we have the length L, we have reaction support at A and reaction support at B. So the first task we are asked to do is to calculate the support reactions RA and RB. So guys, to do this thing, the first thing to solve this type of beam, the first thing we have to do is we need to isolate the beam in question. So we have simple support. It is simple supported at point A and simple supported at point B, and here we have a concentrated load P or a point load P. So what we need to do is we need to isolate this our beam. We need to draw the free body diagram of our beam. That is the free body FBD, the free body diagram of this our beam that we are seeing. So the first thing we do is we are going to draw the free body diagram of this our beam. So let's isolate the beam. The first thing we need to do is write isolation. So this is the very first thing we're supposed to do. We draw the free body diagram of our beam. Here we have RB. Here we have RA. We have the total length of L, distance L. Now we have a point load at the center P, the concentrated load or the point load. So guys, from here to here we are going to have a distance, and from here to here we are also going to have a distance. So if from here to here is L, and this our point load or this our concentrated load P is at the midspan, is at the center of this our length. So the length from here to here will be the distance from RA to our center of this beam will be L on 2, and the same here L on 2. So this is the isolation of this our beam that we are seeing up here. This is the isolation. This is RA, the reaction at point A, and the reaction at point B. This is the point load or the concentrated load at the midspan. So we have the length from here to here, from RA to RB is L. So to obtain the distance from RA to P, it is L on 2, vice versa, or the same way manner, from P to RB is L on 2. So this next thing we are supposed to do next is we are supposed to apply the laws of statics. Statics state that for a body, for a structure, or a body, for a system to be in equilibrium, the sum of all the external forces that are acting on that body must be equal to 0. So the first principle of statics we are going to apply is sum of external forces equal to 0. So what are the external forces that we have on this beam? We have RA, we have P, and we have RB. So we are just going to go directly plus P plus RB equal to 0. So we have RA plus P plus RB equals to 0. Now we now take projection on X axis. When we refer to projection on X axis, what we are saying is forces that act horizontally. Are we together? Forces that act horizontally are known as projection on X axis. Now we need to choose our system, our coordinate, our orientation, how we are going to be working. We have here Y. So this is my orientation. I have Y. I've chosen this sense to be my sense of orientation. So I have Y, I have X. I have M of X, my moment. Now, projection on X axis, we discover that there is no horizontal forces on this our beam. There is no horizontal force. So the projection on X axis is equal to 0. Now, projection on Y axis. Now, our projection on Y axis simply talk of the vertical forces that are found on this our beam or on this our structure. So, looking at this beam, we are going to discover that RA is a horizontal, is a vertical force, P is a vertical force, and B is a vertical force as well. Now, we are going to start with RA. The reason why we place this orientation here is to determine the sign of this our reactions or of this our external forces. So RA is moving in the same direction as our orientation, so it is plus RA. P is opposing the sense of our direction we have chosen, so it is negative. So we are going to have a negative P. RB is following the same orientation, so it is plus RB equal to 0. So making RA plus RB the subject of our equation will give us P. So this P will automatically crosses this equality sign, it becomes plus P. So this is our equation 1. We have one equation and two unknowns. Now we apply the next principle of statics. Says that sum of moment of external forces about a particular point, sum of moment of external forces about a particular point is equal to 0. So the center I have chosen, or the point I have chosen to be my center of moment, is at point A. So this is my point A. So the moment of RA about point A is 0. The moment of P about point A is negative P into P. Here is the force. Now we said moment is the product of the force by the perpendicular distance of the lever arm. So we are going to have negative P into the distance from P to my center of moment is L on 2. The moment of RB about point A is plus RB into L. Because it is L, because the distance from RB to my center of moment at point A is L. That is why we have RB into L on 2. We equate it equals to 0. Now we make RB the subject of the equation. So we are going to have RB into L. We are going to have RB into L is equal to PL on 2. So RB is equal to, so we are going to have RB is equal to PL on 2 divided by L. This implies that RB is equals to, so our RB would be equals to PL on 2L. We are going to have RB is equals to PL on 2L, which is equal to P on 2. So RB, therefore our RB will be equal to P on 2. So viewers, this is the value for our RB. Our RB gave us P on 2. So we are going to solve for RA. We have obtained the value for RB. What we need to do is we need to substitute the value of our RB into our equation 1. We know that RA plus RB is equals to P. So RA is equals to P minus RB. So RA is equal to P minus P on 2. So our RA equals to, we look for the LCM, which is 2. So RA is equal to 2P minus P. So our RA will be equal to, to 2P minus P is P divided by 2. So this is our value of our RA. So therefore RA is equal to P on 2 and RB is same as P on 2. So viewers, here we are. This is the simple bit we have solved. We discovered that our RA is equal to our RB. They have the same value. they have the same value. This means a beam on two simple support and a point load, the result of the support reactions will be the same. So a beam on two simple support and a point load, the reaction at A is equal to the reaction at B. So due to symmetry, actually we never needed to calculate everything like this. We simply just needed to look at the beam and say, make a conclusion that due to symmetry, RA is equal to RB. And RA will be equal to B on 2. So a beam on two simple support and a point load, the reaction at A is equal to the reaction at B, which is equal to B on 2.